In this question, the unit vectors I and j are due east and due north respectively. Position vectors are relative to a fixed origin O. A boat P is moving with constant velocity minus 4i plus 8j kilometers per hour. Calculate the speed of P. When t equals 0, the boat P has position vector 2i minus 8j kilometers. At time t hours, the position vector of P is p kilometers. Write down P in terms of t. A second boat Q is also moving with constant velocity. At time t hours, the position vector of Q is q kilometers, where Q is 18i plus 12j minus t times 6i plus 8j. Find the value of t when P is due west of Q, and the distance between P and Q when P is due west of Q. So that's the question then. So let's have a little look at here it is in summary form. So the speed of P, I'll just put it here, because we've got P as the velocity of P is here. So we can just do Pythag. So the answer will equal square root of both sides squared, minus 4 squared is 16, 8 squared is 64. So that's the square root of 80, isn't it? So we can type that in the calculator. Square root of 80, 4 root 5. And that's the speed in kilometers per hour. 4 root 5. At time t equals 0, P is at this point. Write down P. Okay, so it's moving with this velocity and it's at this speed, this position. So P will equal 2i minus 8j, that's its position, plus the time and the velocity vector, minus 4i plus 8j. So at t equals 0, 0 would go in here, and you get 0 here, and you get the initial position. And after t is 0, as it goes forward, it will be moving with this velocity. So this is the position vector for P. Okay, so the second boat Q is at this vector here at time t. Find the value of t when P is due west of Q. When they're due west of one another, P and Q would be, P would be here, Q would be here. So they have the same j value. So for C, so here the same j value, we would need to impose minus 8 plus 8t is equal to, that's the p value, and the q value would be 12, and then it's minus 8t here. That tells us, move the 8t over to be with the other 8 to make 16t. Move the minus 8 over to be the 12 to be 12 plus 8 is 20. So t will equal 20 over 16. A 4 is common, and that cancels down to 5 over 4, which we can write down straight away. 5 over 4 seconds. 20 over 16 is 5 over 4. Tap it in the calculator if you need to. So there's part C then. The distance between P and Q at this moment in time. Well, that's when they have the same j vector. The value of t, which we've done, the same j vector. Now we need the distance. So d. The answer will be just the magnitude of the difference between the x coordinates, won't it? Because the y coordinates will be the same. So the x coordinate for P is 2 minus 4t. T is 5 over 4. 2 minus 4t, and t is 5 over 4. That position, take away the position of Q, which would be 18 minus 6i, 6t, and t is 5 over 4. And that's the difference in the P and Q, the other parts of the problem. So it was the P coordinate, 2 minus 4t, take away the Q coordinate on I, 18 minus 6t. There we are, that's the difference. Modulus of that. So 2 minus 5 is minus 3. 4's cancel. Here we've got 6 and 4 is 3 and 2. So we've got 36, 15 over 2. 36 over 2 take 15 over 2 is 21 over 2. That's what it looks like to me. Tap it in the calculator if we need to. 15 over 2. 18 is 36 take 15 is 21. So it's a plus 21 over 2 in here, and then the minus makes it minus. So we get, this is 6 over 2, so it's 27 over 2, and we drop the minus because it's a modulus, or 13.5 kilometers.